Hi guys, Mr. Gillen here. Just going to go through a few more examples and during this video and concentrate on some of the more uncommon or unusual ways that arts and sectors come into play during the National 5 course. So for our first example, we are asked to find the length of the arc. So the distance that we're going to be looking to find is this distance here. Bit different from our previous examples. We've not got a full circle here, so we're only given a sector of a circle or a part of a circle. We're not going to change anything about how we're going to find this. We're not going to change anything about the process. What the big difference with this example is purely visually in the drawing and the picture, it looks different to what we've seen. So it's something that you might come across when you're doing some classwork, and I just want to make sure that you're familiar with it. So the first thing that I'm always going to do, same with the previous examples, is I'm going to make sure that I've wrote down a list of what I've got. So looking at the diagram, I know that my radius is 8 centimeters, which means that my diameter is going to be 16 centimeters. My angle is 72 degrees. And as always, pi is equal to 3.14. Same with the previous examples. Again, I'm not going to change anything about my process here. The only real difference is the diagram, and it's not a full circle. So my arc is equal to my angle over 360 multiplied by pi d. And remember, we're never going to go into substituting straight from the start. We're always going to write down the formula. Once I've got it written down, however, I am going to start substituting. So my angle, refer over to my list, my angle is 72 over 360 multiplied by 3.14. The pi and d are stuck together. We know in maths that that is multiplying. So multiply by 16. You can use your calculator for this. So when you put it into a calculator, you'll get 10.048. And it comes out exactly as that. So I don't need to do any rounding. But what I do need to do is make sure I've got my measurement in, my unit of centimetres. It's a length, and length always has a unit in it. So there's no change in the actual process for this particular example. The only thing that's different is the diagram. Okay, let's look at number 2 then. If the length of arc PQ is 16.8 centimetres and the radius of the circle is 24 centimetres, calculate the size of angle POQ. So first thing that stands out to me above anything is I'm not being asked to calculate the length of the arc. I'm asked to calculate something different. I'm actually looking for the angle. And if I look at my diagram, the only thing that's in the diagram at the moment is my radius. So if you're doing this in your jotter, I would make a quick sketch of the diagram. If it was in a test or if it was in a prelim or an exam, then, and you're allowed to write on the sheet, then what I would be doing is, before anything, I'm going to add in 16.8 on the arc so that I can see visually what I'm looking at. And the angle I'm looking to find is going to be this one in here. So that's what I'm trying to find this time. I'm going to still write my list at the side. So my radius is 24 and my diameter is 48. I don't have my angle, but I do have my arc, which is 16.8, and pi is still 3.14. And I'm going to start the exact same as usual. I'm going to put in my formula as I know it. So my arc is equal to the angle over 360 multiplied by pi d. And usually what we would do is we would just substitute in our values and we would carry out the calculation. At the moment though, that formula is giving me the arc length. So what I'm going to do is I'm going to use some previous knowledge and I'm going to change the subject. I'm going to change the subject. In this case, I'm going to change the subject to angle. That's what I want to find. That's what I want on the left-hand side, and I want it on its own. So the first thing that I'm going to do is I'm going to bring the 360 up. And if I'm multiplying by pi d on the right-hand side, when it comes over, it's going to be dividing by pi d. So when I rearrange that, it'll look like the angle equals 360 times the arc over pi d. So all I've done there is I've changed the subject. If you can't remember how to do that, then I would suggest going back to watch the video. It's on the YouTube page and potentially in the Google Classroom as well. Now that I've changed the subject over to angle, I'm good to substitute in my values to actually find out how many degrees are in the angle in the diagram. So my arc is 16.8 and I've got 3.14 multiplied by 48. At this point, I am going to do the numerator and the denominator separately. The reason that I'm going to do that is I want to reduce the amount of mistakes that I can potentially make. So 360 times 16.8 is going to be 6,048, and 3.14 multiplied by 48 is 150.72. At that point, I'm then going to carry out the division. So make sure you're showing your working, make sure you're putting those two figures in your working. When you do the calculation on the calculator, you will get 40.127388854. And I'm going to round that to 2 decimal places. So my angle is 40.13 degrees. Big points in that one will always be identifying the fact that I'm trying to work out an angle. So that's the main part here. We're not being asked to work out the arc. And then being confident with changing the subject in order to get the angle on its own. I will always write out a list on the right hand side because I feel for me it makes things easier to do. So I would recommend that you do it as well. And then from there, we're just going to follow our process. We've got our formula, we substitute in, and then we simplify down, and if necessary, appropriately round. Okay, last example then, a bit of a more worded question. where we potentially have to draw our own diagram. So we're told that the boat on a carnival ride travels along an arc of a circle, centre C. The boat is attached to C by a rod that is 6 metres long. The rod swings from position CA to position CB. The length of the arc AB is 7 metres, and we're asked to find the angle through which the rod swings from position A to position B. And we're given a diagram of the ride itself. So there is the centre of what would be the circle, and we can pretty much see that we do have a sector here. We can certainly see there is an arc, and there's point A and there's point B. If I was doing this, I would always draw a separate diagram that allows me to annotate it, that allows me to draw on it and fill out any information. So I would quickly, not very well, don't tell Mr. Taylor, draw a poor diagram. And we know that the rod is 6 metres, so that's 6 and that's 6. And the arc length is 7. And there's A, and there's B, and up there's C. So that gives me a bit more of an idea of what I'm dealing with. I'm also going to make sure that I'm writing my list down. So I've got my radius, which is 6. So my diameter must be 12. I'm trying to find the angle, so I know what my arc is, and pi, as always, is going to be 3.14. So now that we've actually broken that down and we've got a diagram and we've kind of looked through the words that we're given, we've extracted the information. It's not actually different to the previous example. So the first thing that I'm going to do is I'm going to write out my formula. Start my standard formula. And again, that's the formula that gives us the arc length. I want to be finding out what the angle is. The question is asking me for the angle. So that's what I'm going to work towards. I'm going to change the subject of the formula so that I'm going to get the angle. We saw that in the previous example. So what we'll finish with is angle equals 360 multiplied by what the arc is over pi d. Now that I've got that subject changed, I'm good to go ahead and substitute my values in. So I'll have 360 multiplied by 7 over 3.14 times 12. Like the second example, I'm going to do the numerator and the denominator separately because I want to reduce the amount of mistakes that I can potentially make. So 360 times 7 is 2,520, and 3.14 times 12 is 37.68. Once I've got those two values, I can go ahead and do the division itself in the calculator. 2520 divided by 37.68. What the answer will give me is 66.87898. So I'm going to round that to 2 decimal places. 66.88. It's an angle, so I've got to put in degrees. Things to look out for with this example. Well, if you're not given a straightforward diagram, if you're given a diagram that's maybe got extra pictures on it, it's always a good idea to draw your own diagram so that you can annotate it and it makes it a bit easier. Changing the subject is going to come in again. I have rounded my answer to two decimal places. However, sometimes you might find that the questions will ask you to give your answer to two significant figures or three significant figures. So if it did that, then I would round my answer accordingly. Remember, if you can't remember significant figures, the YouTube channel has got a video on there. Okay, guys, that is all from me just now. As always, if you have any questions, please don't hesitate to get in contact with us. This is Mr. Gillen signing off. Speak to you all soon.